Hi again, this is Khalid Al-Badri, and this is the third and last part of my presentation. In this section, I will talk about Foreman provisioning, how to create Foreman boot disk, how to do bare metal provisioning of a system, how to do a fully automated installation of the platform, plus the application. Okay, so let's start with the Foreman boot disk. To configure Foreman, we need to go to Hosts, Provisioning Templates. The boot disk plugin for Foreman can be used to create a boot ISO in a similar way to Cobbler build ISO in Satellite-5. Foreman can construct a boot disk for the specific host being provisioned and point it to the satellite so that it can be kickstarted properly. Okay, so if we start with provisioning templates, which will be needed to prepare the provisioning process. So when using Foreman boot disk, there are essentially two parts to the provisioning process. There is the PXE process and then the actual kickstart. Foreman refers to these respectively as the iPXE template, okay, and the provisioning template. So the iPXE template is used by the boot disk to create the initial bit of stuff that goes into our ISO to cause the booting system to reach out to the satellite. The provisioning template, however, is the actual kickstart part. So first we need to make sure that the PXE templates are associated with our operating system. So if we need to make sure that we are in the right organization, the right location. Then if we go to Hosts, Provisioning, Templates, okay, then from here we can first configure our iPXE, so the Kickstart default iPXE. And this is just to go through this and make sure that this has been associated to our selected item. In our case it's rel 6.5. okay, then we will need to do the same thing with the Kickstart default PXE Linux association, and as you can see again rel 6.5 has been associated here. Okay, now the OS association makes the Kickstart default iPXE, okay, template available to systems provisioning against the rel server 6.5 operating system. We have also made it available to systems that PXE boot, so either from the ISO or from the PXE boot. The next step is to make sure a Kickstart template is associated with operating system. So if we go to provisioning templates, again it's on the same page, and then we go to My Kickstart. So this will be the Kickstart that I will be using to provision systems. Then if we look at the type, so as you can see this is a provisioning Kickstart. And again association, this is related or associated to rel server 6.5, which is my base operating system here. Okay, now next step is to configure the operating system. So each operating system, major or minor release, can be treated independently for provisioning and other purposes. Since we're going to be operating in a standard operating type environment, we will simply make changes to rel 6.5 and leave it at that. So if we go to Hosts and Operating Systems, then I have already prepared an operating system that is called rel server 6.5. If we just go through the steps I did initially, so this is the name, the major version, the minor release, the description, the OS family, the architecture type, then the partition table. Well, I choose to use the default Kickstart partition table, which would be more than enough here, but of course we can also customize it. Then installation media will be RHEL 6 media. In terms of templates, so these are the templates that we have configured in the previous steps. So the iPixie, the Pixie Linux, and the provision. And at this point, we have made sure that everything is associated and published. We also have a promoted development media with the RHEL 6.5 operating system that has our specific partitioning, provisioning, and Pixie templates. Now, provisioning systems also requires defining what subnets on which systems will be provisioned. So we will need to configure subnet. If we go, subnets are under infrastructure. I have already created a subnet that I called VMnet. Again, if we just go through it. So this is my subnet. This is the network address, the net mask, the gateway, the start IP range and IP range, the domain my system will be part of. So my capsule, the capsule is equivalent to Red Hat satellite proxy. So it will offer services like TFTP and DNS, which can be required for the bare metal provisioning. So location, it's my default location. Remember, this is the name of my location. And again, organization, it's my default organization. This is just a name that I choose for this presentation. Okay, at this point, our subnet is correctly created. Now we can move on to creating our host. So creating a foreman host, in order to provision a system with satellite-6, first we need to define that system by creating a host in foreman. We can then generate a specific boot ISO from that system. So foreman boot disk actually uses iPixie under the covers, which leverages HTTP as its transport protocol as opposed to TFTP. When we define our host, we will need to feed it a MAC address so that the foreman server knows which system is making the provisioning request. This is very similar to how TFTP Pixie looks for the incoming MAC address to determine what to serve the client. So let's do that. If we go to host, then we create a new host. I'm gonna call it Pixie client. Okay, so that will be the name of my my host. Then organization will be my default organization, default location. Then for the host group, I will select RHEL 6 SOV group. Okay, the environment, I want it to be part of development. Then okay, what else here? So my Puppet CA and Puppet Master will be my satellite. Okay, same thing for my content source. Okay, then I will be using message of the day and NTP modules. For the network, I will be using the default domain. And for the MAC address, I will just give any MAC address here. So 52.54.00 CA92 EE, for example, double one. Okay, so choose the subnet that we previously created, and I'll just give it an IP address. So let's say 192.168.100. Oops. .100. Okay, my operating system will be x86 64-bit architecture, RHEL 6.5. Okay, partitioning, I will use the default one, and I'll just set a password here, root password. Okay, everything is alright. Submit. So we're almost there. If we were to provision the system right now, in theory, we would end up with a server that was built and configured and attached to Puppet, but not registered. That's because the Kickstart template or the provision template we uploaded uses an activation key, but we haven't created an activation key yet. So next step, preferably, is to create an activation key. An activation key is much like in Satellite-5. So it can be used for registration and to assign a system to things like repo subscriptions, system groups, environment, and content view. So all these attributes will be automatically inherited from activation key. So an activation key, I have already created an activation key for the purpose of this presentation. We'll just make sure it's set up right. So if we go to content and activation keys, we'll see that I have an activation key called satellite SOE. So this is my activation key. Okay, we're gonna just make sure that it's configured fine. All right, so it's, as you can see, systems registered with this activation key will be part of development. They will inherit these subscriptions or will be registered to these repositories. Okay, what else? So systems will be, so that's fine for the moment. We will not go deeper. So we have our activation key already. Now at this point we now have all of the templates set up that we require in order to provision a server into the right host group that will set up both Puppet and register the system. Let's go ahead and generate our boot desk. So next step is the iPXE ISO booting. Now the following steps that I will perform now, these are what you would be doing if you want to build from an ISO image. Okay, this is not what we're gonna do in this presentation because we can boot from ISO. They are all virtual instances. But in this lab we will generate the ISO so you know how to use it. We will not practically use it, but just to show you how to create or generate this ISO. So if you have to do it by yourself, you know how it works. So we just need to go to hosts, all hosts. Then here we're gonna see our new host that we created, the PXE client, and from here we can go and basically, if I click on my client, boot desk, host PXE client image, and then it will start downloading the ISO image that I could use to boot my server. Okay. Okay, so you would normally use this ISO to boot your VM or any satellite client. We will do nothing with this ISO for the moment for the lab purposes. We will use another procedure to boot the VM. So we're gonna use the PXE boot. Okay, and to use the PXE boot, I will just need to kick VM that will be running on my registered client. So I can use virg start and open a console on my PXE client. Okay. So when I will start my VM, it should boot up with using a pre-configured kernel and inetRD. It will then reach out to the satellite, get its kickstart and begin to provision itself. This method of booting is not how you would normally do this in a real environment. It was done to get around limitations in my lab environment. The point here is to build a machine from scratch using a kickstart provided from satellite. Once the provisioning process is done, the system will reboot and we will see actually an error message here. It's due to the limitations of the environment, but I have some workaround about it. So let's follow the boot process. Okay, so this is the error I was telling you about. So this error shows up because my VM is hard configured to use Kickstart, and Foreman has already built my VM, so it no longer offers the Kickstart. In real environment, if I have used the ISO or Pixie boot, I wouldn't see this. To fix this issue in this lab, I will just do some workaround. So I will edit my virtual machine by removing these lines and force the machine to go through the installation. Okay. So I'll just have to restart the machine now. Destroy this should shut down my new system. Pixie client, then -- console Pixie client. Start. Yeah. Okay. Pixie client. Okay, finally. So there you go. Now the installation should be resumed, and by the end of this I should have access to a system which is fully provisioned and configured as what I have put in my host group. Okay, so while it's installing, let's move to a more complicated provisioning example. In the next example, I will show you how to do some more complex installations. For instance, the provisioning of a LAMP server running WordPress, for example. So everything we have done so far has prepared us to be able to deploy a complete application from soup to nuts. The next exercise that we're gonna do will help us to set up content views and promote the correct content so that we can deploy a simple application, let's say WordPress. Okay, so to deploy the WordPress, we need to introduce a new concept, which is the composite content view. So until now, we have only worked with a single content view. Part of the power of satellite-6 is that we can combine multiple content views together into a composite content view. Before we create a composite, let's look at the content view created specifically for WordPress. So if I go to content views, then we will see a content view that I have prepared already, that is called WordPress view. And if we look at the repositories that we have here, so I have both packages repository with 8 packages and also Puppet modules with 4 Puppet modules that will configure Apache, MySQL, firewall, etc. Okay. Now, so now that we have created a view for WordPress itself, we can create a composite content view. This is very similar to creating a regular content view, but instead of selecting repositories and modules for a composite view, we select which versions of views we want to include together. So again, if we go to content views, then we click on SOE web. So this will be my composite content view. So note that this includes 2 content views, which are rel6 SOE version 2 and WordPress view version 1. Okay, so the key should place a system in the development environment under the SOE web content view. So after creating this composite content view, we will need to create an activation key for it. So these are more details about it. As you can see, this is composite equal to yes. So as I said, next step will be to create an activation key. So if we go to content and activation keys, I have created an activation key that I call WordPress. So the key should place a system in the development environment under the SOE web. So it will be in development and the content view will be SOE web. These are the parameters that will be inherited. If I look into the subscriptions, so these are the channels or the products my system will be registered to. So as you can see, there is one product here that is called WordPress. And next step is to create a host group for WordPress. So satellite-6 additionally adds a lot of hierarchical features that were absent in satellite-5. So in the case of host groups, they can be nested. This is something that we couldn't do with satellite-5. So we can have host groups which are nested with children inheriting aspects of the parent host groups. So we will leverage nested host groups in order to create our SOE web hosting group. So let's go to configure host groups. Then I have already created a LAMP WordPress. As you can see, LAMP WordPress is a child of rel6 SOE group. Okay. Just for a matter of reviewing this. So this is the name, the lifecycle environment, the Puppet environment, the content source. This is quite similar to what we have done previously, except that there are more Puppet classes here. So this is the network configuration, the operating system, the root password. We're using basically the same kickstart file, so that's why we're using the same data here. Okay. So the first activation key in here, so because we have more than an activation key, So we have two activation keys here. We have WordPress and we have satellite SOE. The order, it's important here. The first activation key in the list of comma separated keys will determine the content view and environment for the system. As the WordPress key sets the SOE web content view, it's critical that the WordPress key come before satellite SOE in the list here. Otherwise, we will end up without the correct repositories available, since the WordPress product repos are not in the rel6 SOE content view. Okay, so since we already have a provisioned client, we can actually just re-provision it using the same Foreman Pixie boot as before. So if we go to hosts, all hosts, so this is our Pixie client that we have just provisioned. If we look at that guest now, just try to ping it, for example, so it was 192.168.100.100. As you can see, my guest is up and working. I will just reinstall it, but reinstall it with the WordPress LAMP stack now. Okay, so from here, from the graphical interface, as you can see, this system is unlocked, so I still can build it. Once I'm done with it, I don't want to reinstall it anymore. I can just cancel the build here. Okay, again, I could download the ISO image, but I will not use ISO to reinstall it. I will just repeat exactly the same previous steps I did to install the SOE profile. So I will destroy it. Pixie client, then verse start minus console Pixie client. So this will reboot the provisioned client system. After the build is complete, we will once again see the same error message that says it cannot download the Kickstart, and I will have to do the same trick again. So the Puppet configuration here will include the WordPress class, which will automatically pull in all of the required software. The activation keys ensure we are subscribed to the relevant products and repositories. And by completing this exercise, we will have seen what it takes to demonstrate how one would configure satellite-6 to provision an entire system, including third-party software. So I hope the presentation and demo was very useful. Please don't hesitate to contact Red Hat team if you need any further explanation or queries. Satellite, it's an awesome product, and I really thank you for having the time to listen to my presentation. Thank you, and bye-bye.